Hey guys, welcome back to Genius Learning. Let's take a look at Physics 1 problem. We have two masses, M2, M1, and they're connected by a string that is very light, and you have a frictionless, massless pulley. Basically, just ignore the pulley for now. All right, M2, it has mass of 4 kilograms, M1 has mass of 5 kilograms, and you're given that the friction here between this wood table and mass 2 is 0.5, the kinetic friction, mu. All right, so then it says, our first question, draw a free body diagram, right, for M1 and M2. Okay, before we begin, we always want to establish one thing, or at least I do, because it definitely gets tricky if you don't do it first. So let's see. All right, so I like to establish my coordinate system. When this moves and this moves up and down, is it positive or negative? So I'm gonna say that to the right is positive x hat, and to the left is negative x hat. All right, up is positive y. Okay, let me probably clear that up a little bit. All right, positive x hat, negative x hat. And the hat just means the direction, so if you don't know about it, don't worry about it. It's not important right now. And up is, whoa, I completely messed that up. Okay, y, whatever, positive y, you get the point. All right, and then we have acceleration. So this system is gonna move, right? And we have the mass that's here, and we have acceleration going downward, but we don't know acceleration yet. Okay, so let's not, well, we can't put any value to it, right? So, but let's point out the direction. Okay, so we're gonna put that acceleration is in this direction, right? This is all given, so all this information here is just given. The only thing you're establishing is the direction, where it's positive and negative, right? And you're up and down. And so when this thing moves, we're gonna say that it moves to the left because we have 5 kilograms down here and 4 up here. So this is gonna go down because it has more weight. So we know the acceleration is going this way, right? And then here we got going down is negative y hat, and going up is positive y hat. Okay, I think we got everything. So acceleration, which is a vector, marker, going this way. Going down is negative. See, so we got the negative y hat going down. This is terrible. I should not have done this. Should have waited. Okay, just messed up that mark. Okay, so first thing we want to do is establish that positive is to the right, negative is to the left. All right, for this box, positive is up, negative is down. So this thing is accelerating down. So this box is moving this way because mass 1 is greater. This has more mass than this top one. All right, so let's take a look. The first question, draw a free body diagram for M1, M2. All right, so we're gonna start with M1. All right, I made it in green so we know what we're talking about right here. So let's just highlight here. We got positive y going up, negative y going down. All right, so this box here, all right, we have always, we gotta put first a line going down through the middle, which is M1 times z. Everything is subject to mass times gravity, right? So the first thing you want to establish always mass times gravity, and subscript 1, because now we're going to have mass 2, so it's gonna get confusing if you don't keep track. All right, and then we're gonna have tension in the rope. All right, you can call it a force tension, you can call it a couple other things, but this rope, as this thing is going down, the rope is what's holding the mast up, right? Because if there was no tension in the rope, this thing would just fall. And so the tension in the rope is facing upward. So there's tension in the rope. So that force is being applied, and mass times gravity is always applied. And that's the only thing that this thing feels as far as forces, right? Because it's not doing anything to the left or right. All right, so I think we're good for this one. Now let's go to M2, right? In blue, up there we got, this is the dotted line, this is the table here, so we can see clearly. All right, so we have a table, and now it's a little different. So let's look at, here we're gonna put a little key, just to remind ourselves. We got positive X, negative X, positive Y going up, right? So here, the box is on the table, right? And always you got M, G going down, right? We're gonna label it M2. And so then, unlike this box here, this one is on a flat table, and so we have a normal force that's going up. The table is actually putting a force onto the box, because if not, then the box would just go right through. So the table seems friendly, but it's actually exerting a force up on the box, keeping it where it's at. And we have to label that force. We're gonna call it the normal force. All right, the box is pushing down on the table with mg, right? M2 to be specific. So we got that for the Y, the up and down. Now the side to side. All right, so if we know that this thing is moving in this direction, right? It's feeling a tug from this string. It's sitting here chilling, and all of a sudden, hey, you know, it's being pulled, and now there's tension being felt in this direction. Just like this one had tension going up, it's going down and it's being pulled up by the string because the string doesn't let it fall completely. This box here, as it's being tugged in this direction, right here, is feeling that tug from the string, right? And then always, friction opposes the motion. So a lot of people get this confused, right? But as this box wants to move in this direction, right? You think about friction, friction always slows you down. So what direction is the force gonna be? In the opposite direction, always. So if you ever get confused, just think friction is always in the opposite direction. It wants to slow you down, so it makes sense. Wherever the thing is moving, friction is pointing in the opposite direction. All right, so now I think this is good. So we're good here for the free body diagram. All right, let's move on to B. All right, from the free body diagrams, write down the relevant second law equations. So from these free body diagrams, right, we're gonna write down equations that we're gonna be able to use from the Newton's second law that says the sum of all forces is equal to ma. Okay, it's not just F equals ma, it's the sum of forces. And that means that there's forces in the x direction and there's forces in the y direction, and the sum of all that is gonna equal ma. Okay, so just saying F equals ma is not enough, because we gotta describe forces in different directions. All right, so I put green, so we're just gonna deal with this box for now. And we're gonna write down the equations that are relevant here. All right, so we need to know all the forces, right? We're gonna do, so I'm gonna put an arrow here. We're gonna do all the forces equals ma, all right? So this box right here, right, does not have any movement in the x direction, okay? So we're gonna say that it has 0 force in the x direction, that equals M1A. And the A is negative, right? Because this box is going down. Doesn't really matter because this whole thing is 0. So we'll put a little box here, and all that is 0. Right, so the force is here, MA on this side. And you got to be careful because A is going down, right? And down is negative Y, or negative direction. All right, so now let's do in the Y direction. So for this box here, now let's do up and down, which is the Y. All right, so what forces are going up and down? So let's see, from this diagram, we got tension that's going up, and remember, tension going up is positive, right? So tension is positive. Then you got the box, it's experiencing mg going down, right? So that's minus, so that's minus m1g. Remember, you stick to those labels, all right? All of that is equal to, so that's all the forces. You got one force going up, which is tension, the other force going down, which is mass times gravity. These two things represent F right here. So F is all of this. Force is now equal to MA. What M are we talking about? 1. And acceleration, which way is acceleration going for this box? Downward. So we're going to put negative right here. It's kind of awkward, but so equals negative M1A. All right, this is our second equation. The first one produced nothing, it was 0. Now the second one in the y direction is giving us something we can use. All right, so I'm gonna move over this M1G to this side. Basically, I'm gonna isolate T so we can hold it for later. So we got T is equal to, if I move this to the other side, right, I'm gonna still have negative M1A stays. This becomes positive on the other side. So we got positive M1G. Okay, and for now, let's just leave it like that. So I'm gonna box this up. I'm gonna put equation 1. Or could we, okay, so I'm gonna use this. Let's circle this, that's equation 1. We're gonna hold on to that for now. Right, so now doing like we did for here, for M1, let's do that for M2. So now going here, in the x direction, right, of this box, so using the free body diagram, we got this going on and this going on. So to the right, I have friction. That's in the positive x direction. So I'm gonna write down, using green little snake. There we go. So to the right, friction, which is positive, right? That force is being felt. And then we have tension, which is negative. So minus tension. And that's it for the x direction. There's only 1, 2 things going on there. All right, and then we got all of that equal to, so remember, this is the force. Both of these things equal the force, right? Equal to MA. Which M are we talking about? M2 subscript. And then acceleration. Which way is the acceleration going? This thing is moving like this, which is in the negative x direction. So we got negative A. Okay, I'm gonna put it in front of the M, but just know that this negative is for the A, right? So all of this is the force equal to MA. The A is negative, so we put that there. These two things are opposing each other. All right, good. So let's see, let's box it up. So we're gonna box it up here, and let's label that 2. Whoa. Let's label that equation 2. All right, then we got in the y direction. So this box here, what's its force up and down? All right, well, we know that it's not moving up and down, right? It's just going like that, but it does have forces applied to it that are keeping it stable on this table. You got mg going down, which is the box pushing down on the table, and the table is like, hey, I'm gonna push back with the normal force, and that's from the table to the mass. So there's always two person or situation when you have two objects. You have the table pushing up, which is normal, and up is positive y. So here for the y, I'm gonna say that we have n, right? Then minus m2g, don't forget the subscripts, right? So this is the force being applied to this box up and down in the y direction. But now when we have ma, so that's the force equal to ma, there's no acceleration in the up and down direction. So we're gonna say that's 0, right? Because making it 0 is the reason why this box only slides to the left or right. It doesn't, like, you know, jump up and down as it slides. So it slides perfectly on the table, and that's because we're at equilibrium in the y. These two right here are balancing each other out. Let's move this to the right, and we can see clearly that the normal force is equal to m2 times g. You see, so now since they're equal to each other, right, since that's equal to this thing stays still. All right, should we label that 3? Is it worthy? Yeah, let's label it 3. So this is the normal, okay? So these are the equations that we got. These are the relevant equations that we built 1, 2, 3 from using the second law, Newton's second law. All right, now let's move on to C. What do we got? Let me get the ping. Okay. So now using the equations from part B, so 1, 2, and 3, the equations. Right, these equations are 1, 2, 3. From part B, find acceleration when the block is moving. So both of the blocks are moving now. So they're going down, going this way, and we want to find the value of the acceleration now with these given values, the masses and friction with this against the table. All right, before we do that, we need to know another equation. All right, so we got friction kinetic is equal to mu kinetic times the normal. Okay, so in another video, I'm going to show the difference between the kinetic and the static and how to solve for each one. But in this case, we have kinetic, which means it's moving. The static means it's not moving. So this is the formula. You need to remember this. This one too, these are very important. All right, and so we know the normal is m2g. So already we're going to use the equations from part B to start solving for A. So we know this can be rewritten. So let's do that. Okay. So I'm just gonna rewrite it real quick. F kinetic, so friction kinetic is equal to mu kinetic times m2g. Okay, so this is gonna be what I write everywhere I have friction kinetic. Okay, so I just went from the formula, but we found what normal is. I replaced it with that, good to go. All right, so now, what do we got? Now, okay, a little bit of algebra. It's not too bad, so let's see. Let's get another color for this. Maybe blue. All right, so let me make sure I got some space here. Okay. All right, so now here we're gonna solve for acceleration. First, we're gonna start off with putting 2. So we're gonna put equation 1 into 2. So we're gonna put this t, all of this stuff in here. Okay, so first we're gonna put 1 into 2. And you gotta get used to solving system of equations here. This is how it's going to be for most of these problems. So if there were an easier way, I'd definitely not do it, just to show you this first and then maybe do it. but this is the easiest way for solving this kind of problem. All right, we're gonna put all of this value into here. Okay, and so we're gonna get fk minus, now plug in what you have for t, which is this thing. You got negative m1a plus m1g. Don't lose those ones or twos, okay? So we got all of t equals negative m2a. Perfect. Now we got to isolate acceleration. So now we got an equation that has acceleration in it, and we have all the values. We have m2, we have m1, we know gravity on Earth, and friction, we know mu, and we know m2, and we know gravity. So we have all the values here. All we have to do is isolate a. So follow along with the algebra. I'll try not to skip any steps, all right? So I'm gonna distribute this negative into here, right? So I'm gonna put fk stays the same. This negative turns that into a positive, right? This negative turns this into a negative. So I haven't changed nothing. I just distribute this negative sign. Everything stays the same, all right? All I did was this sign into here is positive, this sign into here, that's negative. Now I want to put the a's on one side, everything else on the other side. So I'm going to put this on this side, all right? So I'm going to write fk, okay? I'm going to write this negative m1g equals, this is positive on this side. When I move it over to the other side of the equal sign is negative. So this turns into negative. So I'll write it first. I'll put negative m1a. This went to the other side, turned into negative. This stays the same because it stays on that side. So negative m2a. All right, I'm gonna pull out a negative. Okay, so I think the easiest way to do this is, let's pull out a negative. Let's see. Okay, I'm gonna pull out a negative from this side, and I'm gonna multiply, okay, fine, let's do this. I'm gonna multiply both sides by -1, okay? So I'm gonna multiply this side here by -1, multiply this side here by -1. Whatever I do to one side, I gotta do to the other side, right? So I'm just multiplying this side by -1, multiplying this side by -1. So this side by -1, this is gonna be negative friction, kinetic. This is gonna be positive m1g. These two values are gonna be positive, right? Negative times negative, negative times negative. So now m1a plus m2a, all right? So just to clear up some of those negative signs, it'll be a little easier for us in a little bit. So let's separate the a from here and here, right? These two things have an a in common. So I'm gonna take them out of these two terms. And I'm gonna have m1 plus m2 in parentheses, and I've taken out an a from both. So if I distribute this a back in, I get m1a, m2a, all right? So I just take out an a, and we got a negative friction, kinetic, plus m1g, right? And so now, final move, right? We can write this, that's fine. I'll leave it for another move. So let's divide out this whole thing here and isolate the a. So I'm gonna rewrite this. I got negative friction kinetic plus m1g divided by, I'm gonna divide this whole thing out. So m1 plus m2 equal to a. All right, so I think I ran out of room here, but this is fine. So now we got an expression for a. This is looking good right here. All right, so let's continue on this paper right here. I'm gonna put this equation up here. Make sure I write like this. Maybe I'll write like this. Okay. So I'm gonna continue this equation up here. So I'm gonna put A is equal to negative friction kinetic plus M1G over M1 plus M2. All right, just rewrote this up here. Now I'm gonna fill in everything we have. First, friction, right? We know friction kinetic, we can rewrite like this. So I'm gonna put acceleration, I'm gonna change this to negative. It's gonna be mu K M2G, right? Don't lose all these little subscripts. That's only for friction. Now I got plus M1G, right? That's that. And then M1 plus M2 on the bottom. All right, perfect. Now let's fill in all the numbers. What do we fill in the numbers with? Let's do this. Let's do orange. All right, so we got A is equal to negative, right? Mu is 0.5. M2 is 4. I'm not gonna write the units because we know the acceleration needs to be units of meters per second squared. And there was nothing that we needed to convert. So we're just gonna leave it like that. So for force, kilograms is fine. So we're gonna leave all the units. So anyway, we got M2, which is 4. Gravity, which is 9.8, plus M1, which is 5, and gravity, which is 9.8, right? This is 5, 9.8. Then on the bottom, we got M1, which is 5 kilograms, plus M2, which is 4 kilograms. All right, so put that in your calculator, and if I know how to use a calculator correctly, then we got 3.27 meters per second squared. All right, this is the acceleration happening when this box slides to the left, this box slides down. The acceleration is 3.27. Okay, now we got the last question. All right, so I think that we can do the last question here. So last question, let's see. Let's get a red. So we got C, this will be D. So this will be D, and we have find the tension in the string. So the tension in the string. Okay, so this one's pretty easy because we already have everything we need. So let's take a look. Maybe I'll cover this side. All right, so what do we need? We can use an equation that has tension in it. And we have this equation, right? It has tension equal to all these values, and we know them all. We got M1, which we know. We just found acceleration, right? So we know that. M1 and G. That looks perfect, and it looks easy. We can also use this one, right? We can solve for T, and then we also have everything there. So let me just put both equations next to each other. So I'm gonna do one first. So one, we got tension is equal to negative M1A plus M1G. If we fill out all the values that we know. We got M1, which is 5 kilograms. Acceleration, which we just found, 3.27 meters per second squared, plus M1, which is 5, and 9.8. Okay, so that's gonna give us, we got that, get this, hold on. Oh yeah, this is a minus. So this is a minus, put this is 16.35 newtons plus, this is 49 newtons right here, for a total of 32.65 newtons. Okay, that was the easy way, right? You could have also used, so I'm gonna just circle this equation. We could have used this one, or we could have used this one here. So if we have that, we have friction kinetic minus T equal to negative M2A. We gotta solve for T. So I think I'm gonna put the T on this side to make it positive and move this to the other side. So friction kinetic, I'm gonna move this to the left side, so that's plus M2A. And now tension, I'm gonna move to this side, to the right side. It's negative, so it's gonna be positive. And here, this equation here, right? We know friction kinetic is mu K M2G plus, right here we got M2G, okay, equals tension. So I'm not gonna put in the numbers, but the numbers are exactly the same. So it's just showing you that we could have gone with this option, or we could have gone with this option and get the same thing. I would choose, you know, the easier method. If I was on an exam, I'd probably choose both methods just to make sure, but either one is fine. If you like a little more algebra, a little more pain, go with this one. Definitely, you know, some more work, and maybe you could justify it better. Okay, so there you go. Hope this helped. Thank you for watching.